Hey, if you are looking for a cool gadget to your gaming room or just need a clock, which is able to modification by web browser, you are in the right place and I have something nice looking and useful for you. Everything starts when I realized that I need an extra clock in my room. I spent few days on YouTube trying to find something good looking. I found a lot of inspiration. I asked myself what I required from that clock. It must be big. I want to clearly see it even if I wake up in the night. It must have RGB diodes because I want to change the color every day. It should have a function to randomly change color. It should have a function to automatically reduce brightness at night. There should be possibility to change color or time using a smartphone or web browser. And on the end of the list, there should be possibility to modify the display value in the future. As always, 3D design software is the first step. I need to build something easy to make and assembly. It takes more than a week to print all parts. I use black PLA for the case and white for segment distracting light from diodes. All parts were cleaned by isopropanol alcohol. And now was time to assemble segments with the digit case. The first solution was to use hot glue, but I figured out that the easiest way was to use soldering iron and melt them together. To correct position white segments, I used printed 5mm distance cube. Definitely the most boring part was to soldering LED chains and glue them to the white segments. To meet my requirements, I decided to use WS2812B RGB diodes from the LED straps. I cut them in group of 2 and soldered them into the chain using short wires. Using 2 LEDs per segment gave me a better brightness option and smoother color changes. One chain was composed from 7 groups of 2 LEDs. It were 14 LEDs per digit and I need 4 the same chains. You shouldn't forget to check the chain before glue them to the digits. I forget that, but fortunately everything worked just fine. For the main timekeeping element, I use real-time clock DS1307 on a tiny RTC board. It's really simple in use, got I2C communication and integrated RAM memory with battery as energy backup. To communicate with it, I wrote a simple library based on datasheet and timekeeping register. If you don't know how to do that, I suggest to watch cool video about it created by Great Scott. I will link it in the description of this video. To control color and brightness of LED diodes, I use Adafruit NeoPixel library. The main controller in the test phase was Arduino Uno, which I changed later for Wemos D1 Mini with ESP8266 on the board to get extra remote function. When I change control board, I need also a logic converter to convert 5V signals into 3.3V used by ESP chip. When I checked that everything is okay and no more modification in the control board were needed, I collect everything together and soldered them into the board. As brightness sensor I used common photoresistor with voltage divider and connected output signal into analog input of microcontroller. Photoresistor was glued in the double dot case between digits. The last step was to screw digit case to each other. Correct arranging the wires, connect all LEDs to the 5V and ground rails using Vagot terminals, and place all signals wires in one big chain sequentially from one to the next one. Connect rails to the 5V 4A power supply, and place the cable blockade to set power wire in the right position. When I finally close everything together, I can connect clock to my MQTT broker, which based on Raspberry Pi Zero. Connected to my network and used Mosquito broker together with Node-RED programming tool. As you can see, clock change brightness depending on the light in my room. And the data transfer between clock and MQTT broker works pretty well. If you want to build it on your own, you can find all files, STL models and Arduino code in the description under this video.